Alright, so now I'm going to look at the application problems that was given on your review. So we're going to start off number 15. It says the time in seconds that it takes a car to travel a quarter mile when starting from full stop can be estimated by using this formula. So T equals 5.825 times the square root of W over P, where W is the weight of the car in pounds and P is the power delivered by the engine in horsepower. If the quarter mile time for a 3,595 pound car is 13.4 seconds, how much power does the engine deliver? Round to the nearest horsepower. So they tell us that the weight of the car is 3,590. This is what's given. And the time is 13.4 seconds. They want to know how much power is the engine delivered. So what I'm going to do is plug in what I know. My T is 13.4 equals 5.825. Square root of my W is 3,590 over P. Now, you can either solve, because we're looking for power, you can either solve for P first, then plug in your values, or you can plug your values in and then solve for P. Either way, it doesn't matter. Just make sure you do the right algebra steps. So the first things first, I need to get rid of this 5.825. Since it's multiplied, I'm going to divide. So I'm going to plug that in my calculator. So I have 13.4 divided by 5.825. And so I'm going to get a big number, right? So I have my answer. So it's like 2.3004 equals the square root of 3,590 over P. So the next thing I'm going to do is to get rid of the square root. I'm going to square it. Now I want to keep my numbers running because I don't want to round too early because I don't want to get the answer wrong since your test will most likely be multiple choice on this part. So I'm going to square it. All I'm going to do is hit the square button and it's going to square what my answer was previously. So I get 5.29 equals 3,590 over P. Now to make the fractions line up, I'm going to put it over 1. And then I'm going to cross multiply. So 5.29p equals 3,590 times 1 is itself, and then divide by 5.29. So in my calculator, I'm going to write 3,590, punch that in, and then hit the division sign. And if I want to pull up the answer that I had previous, I'm going to hit the second button right here. And then the negative sign, second answer. So it pops up the answer I had before. And then my answer is 678.39. And they want it to the nearest horsepower, so I'm going to put 678. So horsepower. There we go. That is my final answer. Okay, so let's look at number 16. Number 16 says the time in seconds t required for an object to fall from a certain height can be modeled by the function t equals the square root of h over 4, where h is the initial height of the object. Find h if t is 25 seconds. So I'm going to rewrite my formula. T equals the square root of h over 4. And they want to know what is h when my t is 25 seconds. So just plug that in. 25 equals the square root of h over 4. I'm going to write 25 over 1 so I can have a fraction equals a fraction. Cross multiply. So 25 times 4 is 100. So I get 100 equals the square root of h, because the square root of h times 1 is just the square root of h. And then I'm going to square both sides. right? So the square root and the square cancel. So then 100 squared is going to be 10,000. So you have 4 zeros. So your H is, what is it? Feet. So 10,000 feet. That's it. All right, last one, number 17. It says, given this diameter equation, right, solve for W. I'm going to do this one on the actual review. So they want us to solve for W. So I'm going to make fraction equal fraction. Cross multiply, so pi d equals the square root of 15w. Now they didn't give us anything to plug in, they just want us to get w by itself. So to get rid of the square root now, I'm going to square both sides. So pi d squared equals 15w. And then I'm going to divide by 15. So your w equals pi d squared over 15. Another way you could write it is distribute the squares, so you get pi squared d squared over 15. Either way I'll accept, but just know that both of them mean the exact same thing.